Welcome to Chemistry White. What is psi and its significations? Psi has no any physical signification, but when used square of it gives the probability of finding the electron in a particular area in atomic orbitals. Next, so let's say psi star d dou, it gives the probability of finding electron in small volume d dou, where d dou equal dx dy dz. It means it gives the small volume in the 3 coordinates. Next, d is the direction of electron, psi star is the complex conjugate of the psi. So psi and psi star always positive and the real. It gives the probability of the finding electron. Next, when psi star value is found very high, it means it is the atomic orbitals where the electrons are usually found. Next, if where we get psi star value is 0, it indicates nodes. Node is the where probability of finding the electron is 0. So by this psi square value we will get easily indicate the probability where our electron will be found. Next, wave function can be given in two terms of Cartesian coordinates and polar coordinates. See, first one, Cartesian coordinates, psi x y z. It means where x y z are the Cartesian coordinates or the position coordinates. It may be given polar coordinates. Polar coordinates, psi or theta pi or in L, theta L m, pi m, where or theta pi are polar coordinates. These all are polar coordinates. Here R, N, L, R is the functions of N and L. N is the principal quantum number, L is the azimuthal quantum number. Next, R, N, L, it depends on the radius, it is called radial wave function. Here theta L m, theta is the functions of L and m. L is the azimuthal quantum number, m is the magnetic quantum number. Next, theta L m depends on the angles, it is called angular wave function. Next, pi m, here pi is the depends on the angles, it is called angular wave function. M is the magnetic quantum number. Next topic, radial probability functions and radial probability distribution curve. It is denoted R square n L. The radial probability function or radial wave function denoted by r square n L. R square is the probability function, so we should take it r square. See the below the diagram of the atom. Outer side is the thickness, and see the nucleus, and distance from nucleus to first orbitals is r, and dr is first orbital between second orbital. So totally r plus dr. Now we have to find out the probability of finding the electron in the shell. The thickness of the shell is dr, and we can calculate the total volume of the shell will be equal to 4 pi r square dr. Now how we can calculate the probability of the electron for this atom? Let's say we will multiply with the probability function, it means r square. So the probability of finding the electron in the small shell of thickness, so dr equal to r square nl int 4 pi r square dr. Next topic, radial probability distribution curve. What is this curve tells us? This curve tells us the distribution of probability of the charge density of the electron around the nucleus. It means radially, and where the probability will be maximum and will be minimum. Next, when we take the plot of 4 pi r square to capital R square nl against r radius becomes the diagram at 1s orbitals. See the diagram, plot against 4 pi r square capital R square and nl. See the diagram. The minimum energy level denoted is 0, and the maximum probability of the electron is 0.53 Armstrong. And again down the curve there is also 0 probability finding the electron. It means at 0 there is no any probability of the finding the electron, it means 0. And the maximum curve, it is denoted maximum probability of the electron the at space in atom. Next, the probability increase and we get maximum value 0.53 Armstrong from the nucleus. Next, in this curve there is no node because there is no another probability equal to 0 for this orbital. Next, at 2s orbital, see the diagram, same like this. 0 is the no probability. Next, here also present one node, and a maximum curve is denoted by the maximum probability finding the electron. Next, in this curve there are two maximum curve, one is the smaller and another one is the bigger. At 1s orbital the electron spends some of the time around the 1s orbital. At 2s orbital the electron spends most of the time around the 2s orbital, and there is a node between 1s and 2s orbital. It means the probability finding the electron is equal to 0. See next, at 3s orbital, see the diagram, take the plot against 4 pi r square capital R square n L. See the plot. The minimum curve denoted 0 probability and the maximum probability of finding the electron almost there. Here also two nodes present. See, in this curve there are 3 maximum probability of the electron, and first two curve is smaller, another one is bigger. There are present two nodes. See next, at 2p orbitals, see the diagram, take a plot against 4 pi r square and capital R square nl. 0 it denotes there is no any probability finding the electron. See the maximum curve 0.53 Armstrong. Here maximum probability finding the electron. In this graph for the 2p orbitals, same for the 1s orbitals. So both are same like this. This is because the 2p orbital is the lowest p orbitals. See next, at 3p orbitals, take the plot against 4 pi r square capital R square nl. There is also like this, 0 means there is no any probability of the finding the electron. On the right side, the maximum probability of the finding the electron, it denoted the maximum curve. There is present one node. In this graph also similar for the 2s orbitals. There is also no node. There is also one node present. At 4p orbitals, take a plot against 4 pi r square capital R square nl. There is also found two nodes, two smaller, one bigger. See the bigger curve, the maximum probability of the finding the electron is denoted that space. In this graph also similar for the 3s orbitals, there is also two nodes present. At 3d orbitals, see the first 1s orbital, 2s orbital and 3d orbital will be same. See the diagram carefully. Take a plot against 4 pi r square capital R square L n. There is maximum probability of the value 0.53 Armstrong. 0 is denoted there is no any probability of the finding the electron. Note carefully, note The graph for the 1s orbital, 2s orbital and 3d orbital will be the same. At 4d orbitals, take a plot 4 pi r square, capital R square, n l. See the diagram. There is found one node. At a smaller curve found another one is the bigger curve. The bigger curve denoted the maximum probability of the finding the electron. In this graph, for the 2s orbital, 3p orbital and 4p orbital will be the equal the same. So always same. At 5d orbitals, take a plot for pi r square, capital R square, n l. See the diagram. There is available two nodes, two smaller curve, one bigger curve. At a bigger curve, the maximum probability of the finding the electron, it is denoted. See the diagram well. The graph for the 3s orbital, 4p orbital and 5d orbital will be equal the same. There is presented two nodes also. Next topic, radial nodes formula. What is the radial nodes formula? The number of radial nodes equal n minus l minus 1. This is the formula for radial nodes. For example, at a 3s orbitals, 3s equal to 0, 0 is c above, 0 is n. Okay, 0 minus 1. Here 1 means l equal to, again see n is denoted 4d orbitals equal, here also l is 4 minus 1. Here two nodes, so 2 minus 1 equal 1. So 4d equal 4 minus 2 minus 1 equal 1. Here n is the principal quantum number, l is the azimuthal quantum number. Next we will see for the one example. For 2p orbitals equal to 1, wait, for 3d orbitals equal to 2. Here l is the azimuthal quantum number. Next, angular wave function. Angular wave function always depends on the L and M values. And it is represent the atomic orbitals. Here L is the azimuthal quantum number, M is the magnetic quantum number. As the angular wave function depends upon the angles, so the shape of the atomic orbitals also depends on theta and pi values. Let's see now how the angular wave function where rise the orbitals. See the diagram. L, M, L is the azimuthal quantum number, m is the magnetic quantum number, orbitals, angular wave function. L0, m also 0, orbitals, s orbital, the spherical shape of the orbitals. Angular wave function 1 upon 4 pi 1 upon 2 1 0 at p orbitals, pz. Angular wave function 3 upon 4 pi 1 upon 2. L is 1, m is 1 at p orbitals, it means px. Angular wave function 3 upon 4 pi 1 upon 2 sin theta cos pi. L is 1, m is minus 1, or p orbitals, it means py. Angular wave function 3 upon 4 pi 1 upon 2 sin theta and cos pi. This lecture is over. We will see the next lecture, and hereafter more upcoming videos on the way. Please subscribe the channel and learn easily. Thanking you for all.